This video is about applying the properties of angle pairs formed by parallel lines and a transversal. So if parallel lines are cut by a transversal, then corresponding angles are congruent, which means they're going to have the same measure. So if I have two lines that are parallel in a transversal, my corresponding angles are going to have the same measure. If I have alternate interior angles from my parallel lines and a transversal, so let's say angle and angle, those are also going to be congruent. The same thing holds true if I have two parallel lines and a transversal. My alternate exterior angles are also going to be congruent. Now this switches a little bit. If I have same side interior angles, those are no longer congruent. Those are going to be supplementary, which means they're going to add up to 180 together. The same thing is true for same side exterior angles. So if I have same side exterior angles, those are also going to be supplementary. So let's look at the figures that are drawn below and the angles that are given and see what type of angle pair that would be based on what we know from yesterday and then the relationship that we just talked about. So in number 1, angle 1 and angle 2 are both above their respective line on the same side of the transversal. So these would be corresponding angles. Remember that corresponding angles then have the relationship of being congruent. Number 2, we have angle 1 and angle 2. They are between our parallel lines, which means they're on the interior, and they're on opposite sides of the line. So these are alternate interior angles. Alternate interior angles are also congruent. Number 3, we have two angles on the exterior that are on opposite sides of their transversal. So these are going to be alternate exterior angles, and alternate exterior angles are congruent. Number 4, we have two angles that are between the line and they're on the same side of their lines. So these are going to be same side interior angles. Same side interior angles are supplementary. So a way to remember that too is they start with S's, so they have to be supplementary. Number 5, my angles are on the outsides of the parallel lines and on the same side of the transversal. So these are going to be same side exterior angles, and the relationship here is that they are supplementary. So let's use this idea now to solve for a variable. So number 6, we want to solve for A. These little arrows on B and C mean that the lines are parallel, which means that A is my transversal. So if I look at the angles, they're on the same side of the transversal, and they are inside the lines, which means they are same side interior angles, and same side interior angles are supplementary. So we're going to add the two angle measures together and set them to equal to 180 to solve for x. So I can combine 125 and 15, so I get x plus 140 equals 180. I can subtract 140 from both sides, which means that x is 40. Number 7, solve for x. So again, I have parallel lines with these two arrows, and M is my transversal that's passing through them. So if I look at these angles this time, both angles are in the same spot in their group of 4. They're both in the lower right side, which means that they have to be congruent angles because they are corresponding. So corresponding angles are congruent, so I'm going to set them equal to each other. I'm going to solve by subtracting 10 from both sides and dividing by 4. So x is 25. Now, solve for x and then find the measure of angle 1. So at number 8, when I look at my arrows, these arrows are telling me that the lines are parallel and I have my transversal. So if I look at just the angles for now and I ignore where number 1 is, They're on alternate sides of my transversal, and they're between the lines. So they are same side interior angles, which are congruent. So 5x minus 43 is equal to 3x plus 17. So we're going to subtract 3x from both sides, and then add 43 to both sides. And we get that x is 30. Once we know that x is 30, we can find angle 1, because this angle right here, 5x minus 43, and angle 1 are vertical angles. So I'm going to substitute 30 in for x. So 5 times 30 minus 43 gets me an angle measurement of 107 degrees. And since they're vertical angles, that means the measure of angle 1 has to be the same, which is 107 degrees. Number 9, looking at my angles, I have my parallel lines and I have my angles on the same side of the transversal and outside of the parallel lines, which means they are same side exterior. So same side exterior angles are supplementary, so we're going to add them together and set them equal to 180. So I get 17x plus 78 equals 108. Oops, sorry, 180. When I subtract 78 from both sides, I get 102. So 17x equal to 102. When I divide, I get x is 6. Now that I know x is 6, I can substitute in for one of my angles. So I'm going to substitute next to the one by angle 1. So 10 times 6 plus 66 is 126 degrees. Now this time, these two angles are forming a straight line. So to get angle 1, they're supplementary. I'm going to subtract from 180, and I get my angle is 54 degrees for angle 1. Now, number 10, solve for x and y. So A is parallel to B, which means that these other two lines are going to be transversals. So the angles that are on the blue line have a relationship together. The angles on the green line have a relationship together. So on the blue line, our angles are on the same side of the transversal and between my parallel lines, which means they are same side interior angles. So same side interior angles need to be added together and set equal to 180. On my green line, my angles are on opposite sides of the transversal and between the lines. So those are same side interior angles. So I'm going to set them equal to each other because they are congruent angles. So my first green equation set up for a system of equations. The blue, we need to subtract 32 and 40 to both sides. So we get 12x plus 6y is equal to, I'm going to subtract 32 and 40 from 180, and I get 108. So now to solve for x and y, we're going to write our equations together and use elimination. So to use elimination, I think it's easier for me to eliminate my x's if I multiply the second equation by -2. So the first equation stays the same. The second equation, everything gets multiplied by -2. So -12x minus 10y is equal to -124. So my x's cancel out and I'm left with -4y is equal to -16. And when we divide by -4, we get y is 6. Remember, once you solve for y, you need to go back and get x. So I'm going to substitute into either equation. So I'm going to use the green one. 6x plus 5 times 4 equals 62. 5 times 4 is 20. And I'm going to subtract that from both sides. So 6x equals 42. When we divide by 6, x is 7. So I get 7/4.